Hello, my dear energetic, joshful students. How are you? So, welcome back to the series of PYQ Power Play Part 3, where we are going to solve four more questions from 2023 paper. Right? So, we are not going for quantity, we are going for quality. We are going to go in depth in these four questions and learn the problem solving skills. We are not learning those four problems, we are actually enhancing our problem solving skills. So before I start, a little brief introduction about me. My name is Bhavdeep Sethi, and I have a big passion for teaching. I have a big passion for physics, and I have been converting physics haters to physics lovers. And I always say, physics को रट्टा मारोगे तो physics बुरा मान जाएगी. So you should never memorize physics. You should learn it with basic concepts out there. Nature is your best teacher for physics. Learn physics with nature. Now, what should you not expect from this session? As always, no spoon feeding. If you're expecting that Bhavdeep sir is going to present the question and give all the steps to solve that question, no, that's not going to happen. This session is all about learning the problem solving skills. I'm going to show the problem, I'm going to discuss about the concept behind it. I may solve the entire question, I may not solve it. It depends on how much time we have, and it would rather be beneficial for you if I do not solve it completely, because then you go back and proceed further. That's how you learn how to solve problems. So spoon feeding is something you should never expect from any of my sessions, including this one. Now, first things first, obviously the dates are out. So NSCP this year is going to happen on Sunday, 24th of November at 8:30 a.m. Now, how do you register? You go to the website of IAPT and enroll. It's from August 21 to September 14 is when you can enroll. So the dates are open right now. Go right now and fill the forms. Now, if you're confused about how to fill the form, our VOS master teacher Nidhi ma'am को कौन नहीं जानता? So Nidhi ma'am has created step-by-step guide for you. So she will walk you through the entire process, because let me tell you, this form is a little lengthy and it's also a little confusing sometimes. You might not see your city or your school, and Nidhi ma'am will actually walk you through, and she will ensure that this is a smooth journey of filling the form so that you do not make any mistakes. So see that video on VOS website. And then further regarding the eligibility criteria, this is from the website, but I have made videos on how to, you can simply understand how you can find out whether you are eligible or not. First of all, if you are in 8th or 9th grade, NSCJS. So please go to Nidhi ma'am. She takes awesome classes for those. But if you're in 10th, 11th, and 12th, 11, 12, you can definitely give NSCP. But if you're in 10th, there has to be a cutoff date. You should be older than a certain date. So you go through my video on that. Now let's also, the number of questions we are expecting is going to be the same this year also. So 60 questions, 216 marks. So this paper is not just about solving the questions correctly, it's also about the time management skills. So let's start the question paper right here. Now this question, a very easy question, I would say, question number 9 in 2023, and depending on which set you're looking at, the density of a liquid is rho at the surface. So you have some liquid here, and the density is rho at the surface of that. The bulk modulus of liquid is given as B. The increase delta P in the density of liquid at the depth h from the surface is. Now, looking at the question, it's pretty straightforward that if you are at the surface, density would be less. Here it will be more. Why? Because if you're squeezing the packets of or the molecules together because of more pressure, the molecules will be more denser, right? So there's less pressure on the top, more pressure there. So you squeeze them, it's going to be a positive change, kind of more density there. But they're saying, okay, how much is the density in terms of these variables? So let's start working on this easy question. This one is really easy, by the way. So how do we proceed? We know the change in pressure is H rho G. So we have to see how much is the contribution of that. So we can say, okay, we start with density. Okay, what is density? Density is mass over volume. So how do we relate all this? So mass will not change. Mass will be conserved from here to here. Obviously, going by the energy mass equivalence, the mass may change, but those changes are so tiny that in all our practical purposes, we just ignore them. So mass here is mass here. So density and volume are related here. So we can find those kind of relationships. So let's get started. So we know mass will be density times the volume. Density is mass over volume. So this is our starting point here. Now we are talking about the changes in density, then changes in volume because of the bulk modulus out there. So what is bulk modulus? Bulk modulus would be the stress. What is stress? Stress is the change in pressure here divided by the strain. Now what is strain? Delta V over V. That's the strain. So we are talking now. We are relating few things here. So somehow we have to relate delta rho with all these variables. So delta rho, as in we have to find changes here. So you take the derivatives on both sides, or let's go for deltas here. So this doesn't change. The left hand side remains zero. So this becomes by the product rule here. So you will get delta times or rho times delta V plus V times delta rho. And that's just the product rule for calculus, right? Now you rearrange all this, what you get is delta rho by rho comes out to be negative of delta V by V. Now what does that negative sign signify? See, we are not just solving this problem, we are analyzing it. So we'll spend a lot of time on this. And that's one reason I'm just picking 4 questions here. So what does this negative sign signify? It says, okay, the change in density is in the opposite direction of change in volume, and that's common sense. Because if the volume is decreasing, density should increase. And if the volume is increasing, density should decrease. So that negative sign is simply telling us the direction of changes. It has nothing to do with algebra over here. Now we want to know how much is change in density because they're saying how much is the increase in density here. So density change is equal to this much, but then this doesn't match any of the answers. So I'm saying, okay, delta rho to me is ignoring that negative sign. Obviously, that's telling me the direction. This, okay, now I don't have any option. So I see, okay, in the options, it's all bulk modulus and all that. So yeah, let's go and bring in delta V by V as this. So what is delta V by V? So let's replace that. That is delta P over V. But what is the change in pressure? It's H rho G. H rho G over bulk modulus. So basically now you're done. I mean, you take this here, you plug it in here. Now you have H rho square G by V. Oh, I see this is the right answer. So this is how you analyze the problems, not problems, questions, I would say. Questions are not problems. I don't know why they're called problems. Let's solve problem number 9. It's not a problem, it's an opportunity, right? Yeah. Anyways, so water flows at 1.2 meters per second. Again, a very easy question given in 2023. Through a hose of diameter this, the time required to fill the cylindrical container of 2 meters radius and a height of 1.5 meters. Now, the reason for giving these kind of questions in NSEP exam is all about testing your time management skills also. Because see, the question itself is so easy, you would say, okay, this is more like a volume and surface area chapter from grade 8 or grade 9 mathematics book. Right, that's right. But then when you have these questions, you really have to be very quick in estimations and finding the answers because there are questions that would need more time. So very easy. I mean, there's nothing much to explain. So there is a hose here as in a pipe. So let's say this is a pipe and the water flows through this. So how much water flows in 1 second? So let's say basically if there was a molecule here, water molecule, it is 1.2 meters per second. So this molecule would have traveled 1.2 meters in 1 second. So in 1 second, this would have traveled 1.2 meters. So all those molecules here would have shifted 1.2 meters here. So basically, the flow of water per second would be all these molecules have flown in 1 second. But how many molecules, how much of molecules? Isn't that this cross-sectional area multiplied by this velocity? So this is as simple as saying pi times this d square because d is again pi r square, right? So pi d square. Now this is pi d square by 4. So area is pi r square, but diameter is given. So times 1.59 times 1.59 divided by 4. That's the area, but that's in square centimeters. I needed that in meters. So I'll say, okay, that's 1, 2, 3, 4. That's That's the area over here, multiplied by these many meters per second. So 1.2. So this is the volume of water flowing in 1 second. And now there is a tank over here, and they say the tank radius is given to be 2 meters. So this is 2 meters, and they want to fill it to 1.25 meters high. So how much water do you need? You need pi times 2 times 2 times 1.25. That's all SI units, so no conversion needed. So I need this much of water. In 1 second, I can provide this much. So how many seconds do I need? Okay, let's say I need t seconds. So in t seconds, I would have this much of flow, and then this is equal to this. That's all. You get the answer in seconds. You convert that to meters or hours, whatever matches. The pi will cross out anyways. And you take this further. Now, the whole point of this question is you should be able to quickly estimate. And I'll show you how to quickly estimate, by the way. So think about this, because you need estimations, you don't need exact answers. Can't you say this 1.2? Wow, almost same. Now this is 1.6, 1.6, 2.56, 2.56 and 4, 1.5. Very, very quickly you can cross out this is 1.5. Almost. I mean, I'm not going for precision here. And this is all, just go there and multiply. So that's your answer. Now, a police car moving at the speed of 108 kilometers per hour approaches a truck moving at 72 kilometers an hour in the opposite direction. Okay. The natural frequency of the siren of the car is 800 hertz and the surrounding temperature is 27 degrees Celsius. Now, remember these values of speed of sound and all is all given in your exam paper, but you know it's roughly 340 meters per second. So the frequency heard by the truck driver as the car passes by remains unchanged. Not possible. Not possible. Becomes nearly, decreases nearly by, increases by. Okay. Now think about it. When two things are coming together, the observer, so when the source is coming towards observer or observer coming towards the source, don't you think the frequency would have been perceived as a higher frequency, but then when they go further away, it would reduce. So as it is coming closer, so it's fast, more frequency than less frequency. So it should have decreased, obviously. So frequency heard by the truck driver as the car passes by, not possible. Right, that's not possible. So again, these two options are out, but that doesn't help me much. It helps me, I mean, one way that if I were to do an estimate or a guesswork, I would have guessed 1 out of 4. Now it's 1 out of 2. My probability has increased. But why guess when we know that exactly how to solve it? So don't you think the frequency that you perceive, that the virtual frequency is the actual frequency times the velocity of sound in air plus or minus velocity of observer divided by velocity of sound plus or minus velocity of source. Now, when to use plus, when to use minus, it's not like let me flip a coin, head I have to plus, tail I have to minus. No, that's not how it works. And it's like plus minus. What should I take? Let me toss a coin or roll a die. Even I have to plus, odd I have to minus. No, that's not how it works. So we'll see. You know? So now there's a police car. So let's draw the situation here. So let's say there is a police car, and I don't have much room here. So I'll make this pen a little thinner if you don't mind, so that I have more room to draw. So let's say the situation is initially there is a police car. I mean, I know I'm not a very good artist, but I try my best. So this is a police car moving at a speed of 108. So 108 times 5 by 18. So I know this crosses at 6. So this is 30 meters per second. So this police car is going with 30 meter per second. Now it's approaching a truck with 72. So 72 times 5 by 18. So this gives me 4 and this becomes 20. So 20 meters per second. So there's a truck. I don't know how to draw a truck. So let me draw a box. I mean, I know I'm not a very good artist, but I mean this looks reasonably clear now, right? So this is the situation. So don't you think this is the source and this is the observer, observer is going to hear more frequency because of two reasons. First of all, the observer is coming closer to the source. Secondly, source coming closer to the observer. So how much frequency would be heard by the observer here? That frequency, let's call it F1, is going to be the original frequency, which is 800 hertz times. So let's fill in the numbers here. So velocity of sound in air. So let's take it roughly 340. So this is 340 and this is also 340. Others I'll fill in. So this is velocity of sound in air. Velocity of sound in air that we know is roughly 340 at 27 degrees Celsius. Now velocity of observer. Velocity of observer is 20. Let me plug in 20 here. And velocity of source is 30. Let me plug in 30. Now plus minus we'll see. So how do you feel plus and minus? Plus and minus are based on what is that object trying to do. So let's understand. So what is the action of observer? Observer is trying to come closer. It's all about what is it trying. We don't know the end result, but what is the effort? Effort of the observer is let me come closer to the source. So it's trying to come closer to the source. It's trying to increase the frequency. So in order to increase this frequency, so observer frequency velocity has to be added because observer is trying to come closer. So it is trying to increase. Now talking of source, what is source trying to do? Source is saying I'm going closer to observer. So source is also trying to increase the frequency. So how would you increase the frequency based on this number? You will have to put a negative sign there because if you reduce the denominator, the whole thing increases. So this is the frequency that that truck will observe. Now, once they cross by, they pass by each other. So let's take another color here. So maybe now they pass by. So now this is the truck. Very beautiful truck. I know. Thank you, thank you. So now this is the car. So car is still moving with 30 and truck is still moving with 20. Now we know they're going to they're going further away. So the frequency would decrease. So what would now happen is the new frequency that the truck driver would observe is 800 is the original frequency. Let's put that here. 340 remains 340. 340 remains 340. Now on the top comes the velocity of observer. Observer is still going with 20. So I'll just put 20 there. Source is still moving with 30. I will put 30 there. Now in the new situation where they've crossed each other, what is the observer trying to do? Observer is trying to move away from the source. So it is trying to reduce its frequency, heard. Huh? So to reduce that frequency, I'll have to put a negative sign here. What is the source doing? Source is also trying to reduce the frequency by moving away. So what should I do? I should reduce by putting a plus sign here. So this is my new frequency. So this was originally heard and this is now heard. So this is more, this is less. You subtract them and one of these will match now. So when you calculate this estimations, obviously, and then calculate this, estimate this, subtract, you'll get one of these. So that's how. Right? So the last question today is a beautiful question. It's actually it was part of 2023 NSEP exam, and in one of the sets it was question number 12. Other sets it might be different number, but I was surprised to see this question because this question is so common. It has come in JEE mains exam many times, NEET exam many times, and I usually expect NSCP to give some unique kind of questions. I mean, this is not a unique. It's a very popular kind of question. Many students memorize the formula of this. They know the answer is which one. So let's start solving this. A rope of mass m and length l hangs vertically. The time needed for a pulse to travel from its bottom end to the support is. So let's first understand the concept here. If there is a rope, there's a rope. It has a tension, and you're trying to make a wave or a pulse move through that. The velocity of that pulse or a wave is going to be square root of T over mu. Now, what is mu? Mu is the mass per unit of the length. So kilograms per meter, kind of, right? So there's a rope here. kg per meter. That's mu. That's mass, linear mass density, and that's the tension in the rope. No tension, no velocity. No tension. Okay. No tension, no velocity. So that's so more the tension. Think about it. More the tension, more the velocity, because now you are providing more restoring force. Think about your, sometimes students are confused. ये ऊपर है कि ये ऊपर है. Go by the common sense. I mean, if there's more tension, you will have more restoring force and you will have more velocity. But on the other hand, if you have more of the mu, as in mass per unit length, more mass means more inertia. So wouldn't it now slow down, right? So that's where this is coming from. So T by mu. Yeah, as I said, we are not just solving these NSEP questions. We are learning concepts and learning the problem solving skills. So here the situation is, okay, there is a rope here, and then it is hung like this to the ceiling. And how much, so you start a pulse here, so pulse starts and moves up. How much time would it take to reach up? First of all, you have to understand there is nobody pulling the rope down. Let me provide tension. No, nobody is pulling. I mean, usually you have a rope which is stretched between two fixtures there, and then those fixtures actually they pull. I mean, they provide the tension. You can increase or decrease the tension, but there's nobody here. It's a free, free rope. So where will the tension come from? Tension will come from the gravity. Don't you think the gravity is pulling it down? So mg of this rope is downwards. So if I talk about, so think about this is not a massless rope. So if I talk about this point of the rope will have full mass times gravity of tension. This would have a little less tension because less of the rope is below that. This would have half of the mass times gravity, and this would have zero tension, no tension, right? So can I say that the tension in the rope is varying? It is changing. So can I also say, looking at this, the velocity is also changing. So no tension, almost zero velocity there. Then as the pulse goes up, velocity increases, increases, increases. It is a variable velocity thing. And we are saying how much would it take to reach up calls for some integration, right? So yeah. So when you do integration, you look at the start of the journey, you look at the end of the journey. You have seen my calculus classes. So integration means you start of the journey, end of the journey, you take some intermediary position somewhere. It's not at the middle of it, but somewhere. So let's take that somewhere here. So let us say the pulse is over here, and let's try to understand the situation at that point. So let us say this length here, I'm taking a tiny little length here, dl or dx, whatever. So length is given as L. So let's take it as X, maybe not to confuse with that L, because uppercase, lowercase, still it confuses me sometimes. So let's say tiny little portion length dx at a height of x from bottom. So height x here, dx portion of it. So can I say this much of the rope is providing the tension to that? So that portion of rope has a tension of this much mass times gravity. But one unit of mass, oh sorry, one unit of length has a mass of mu. So this is kilograms per centimeter or per meter times the number of meters or centimeters gives me the mass of this. So how much is the tension here? The tension here is equal to mu times the x times of gravity, isn't it? So that's the amount of tension over there. So how much is the velocity there? So velocity there would be square root of this tension mu xg divided by mu, right? Because that's the tension and this is the mass per unit length. So you can see the velocity is root of xg. Okay, now we are talking. So velocity as a function of position. So I know if position is zero, the velocity is zero and it is increasing. It's not increasing linearly, but at least we know it is increasing and it will be maximum when x is maximum. So this is making sense. So again, when you're solving the question in exam, you just rush through that, making sure you're not making any mistakes. But prior to exam, when you're solving the questions, my dear students, you should actually analyze. Does it make sense? What I have done, does it make sense dimensionally, logically, common sense wise? Yes, it does. Because let's analyze. I mean, I'm really amazed by the depth in which you can go in some of the questions. Have I made any mistake? Well, I don't think so. Looking at the fact that more the x, more the velocity should be. Yeah, this is making sense. But what about dimensions? Why is there a square root here? Why isn't this x to the power 7 maybe? X to the power 3.95 maybe? Look at this. This is meters. X is meters and this is meters per second square. So meters times meters per second square is meter square over second square, and then you're taking a square root, it's becoming meter per second. Yeah, it's making sense, at least dimensionally. Now there might be some constant here, pi, 3.92, pi, something. Yeah, that part I don't know, but at least two ways I can see this is making sense. Okay. No, but I want to know the time taken to travel the entire length of the rope. So I want to relate, so I want to find how much time will this take to travel length L. So yeah, there is x over here, there's velocity here. I can write velocity as dx by dt. Now we are relating x and t, and that's exactly what I wanted. Root xg. And then you rearrange all this. Very, very beautiful question out there. 1 over root g, I'll write it separately. And then x to the power half, x to the power minus half, because think about it, it's 1 over square root of x. So this is x to the power minus half dx is equal to dt. Wow. And then you integrate. What are the limits of integration? What is the value of x at the beginning of the journey? It is 0. What is the value there? It is L. And what about the time? Time, I started my stopwatch here and I want to measure what was the time there. Perfect. Done. And now you just calculate. So x to the power half, integration of that would be x to the power half over half, which makes it 2. And that's your answer. So this let's do that here. So let tiny little space there. So 1 over root g remains as it is. So integration of that would be x to the power half over half. And when you put the limits of L and 0, this becomes L. So this would actually become L. L to the power half is equal to T. So integration of this is T, from T is T to 0. So if you put T minus 0, that becomes T. So what is your answer? 2 goes to the top. So 2 times root L by G. That's what I look at. And this is how you solve the questions logically. But my dear students, one piece of advice, one more time, I'll repeat that. When you're solving these questions in exam, just rush through them, as in take the allotted amount of time. Don't make any mistakes, calculation mistake, conceptual mistakes. But prior to exam, when you're solving these questions, go deep into those, and that's how you learn how to learn. You learn conceptually. I'll make some video on that one day, but for now, let's move on. So if this was easy and helpful to you, please share this video and I'll come back with more such series on this. By the way, we have started this full physics mastery 2025 course, which is a 5 module course. And I have talked much about it, so I'll just go very fast on this. So there are 5 modules. The first 3 modules are 11th grade syllabus, and the last 2 are the 12th grade syllabus. So we have started this module 1 in July. It's over now. On 9th of September, we are starting module 2. If you have not attended module 1, that's okay. You can still join and you'll get this one for free. So we'll not charge you fee for that. So every module is 2,500 rupees. So the entire syllabus of 5 modules was 12,500. But because this one is over, we'll only charge you for 4 modules. That is 1, 2, 3, 4, which is 2,500 times 4, which is 10,000 rupees. And this one will be provided as a free recording. Now, are there any prerequisites? And I always say there are 3 important prerequisites: willingness to learn, commitment to hard work, and Josh. Because many times students come and say, I'm not strong with trigonometry, I'm not strong with laws of motion. Should I think of Olympiad? Yes, you should. As long as you have determination and willpower, you're committed to hard work, yes. तुम सीखने वाले बनो, मैं सिखाऊंगा यार. Now, how to go for this course? Basically, first of all, note down this coupon, which is going to save you 2000 rupees, get 20. So you go to Vedantu website, you click on courses, you click on Olympiad, and there you see full physics mastery 2025. It's very light here, but I'm hoping you can see that modules 2, 3, 4, 5 plus module 1 recording. You click on that, you choose your grade 9, 10th, 11th, whatever, and then you say get started. Now, there you can see it is 10,000 rupees, but here's the best part of it. View all offers. You click on here and write GET20, no spaces, nothing. So GET20 as in get 20. You apply the coupon here and there it goes. It's only 8,000 rupees now. So that's how you can avail this offer. And also this link is in the description here. You can join the course via the link also. Now we have been getting a lot of gold medals and silver medals in astronomy. We recently got one gold and two silver. So India got four silvers. Out of them, two were Vedantu students, and gold medalist was in Vedantu student. And we have been getting a lot of golds and silvers, and we have spoken a lot about them. These students were committed, dedicated for their hard work and goals. So join this Telegram channel for being updated about more programs about Vedantu. And I'm definitely going to come with more such questions here, PYQs. Keep up the high Josh. And you may join that paid course or not, doesn't matter. You keep coming to Vedantu Olympiad school here and keep up the high Josh. I'll be here with you. See you soon.